Deriving the quadratic formula. This video will introduce you to the quadratic formula, explain what it's used for. I'm going to show you two ways of deriving it, and we're going to demonstrate how the quadratic formula is used with several examples. We've already learned how to solve different types of quadratic equations without using the quadratic formula. For instance, any quadratic equation can be solved by estimating its zeros on a graph. This can be solved by square rooting both sides. This one can be solved by adding 10 dividing by 3 and using square roots at that point. And this can be solved in a similar way with one additional step. This equation can be solved using factoring. If we factor the left-hand side, we can easily find the two solutions. And for this equation, it can't be factored, but we can use completing the square to find an exact answer. Here's what the quadratic formula looks like. It applies to a quadratic equation in standard form, and given that equation in standard form, the value of x is the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. And you can use this formula without having to go through completing the square or taking square roots or any other of the methods that we've learned. It will work for any quadratic equation. It is not always the easiest method, but it will work for any quadratic equation in standard form. Brahmagupta was an Indian mathematician, and in his book, Brahma's Correct System of Astronomy, he included a formula which, although the notation was different, is essentially equivalent to our quadratic formula. And he is credited with the one who really first formulated this formula. Now here's how to derive the quadratic formula by taking a general quadratic equation in standard form and completing the square. First, we divide both sides of the equation by a, and this makes it a little easier to complete the square. We then isolate the first two terms, x squared and b over 8 times x, and we complete the square by taking half the coefficient of x and squaring it, adding it inside the parentheses, and subtracting it outside. Next, we factor the trinomial on the left. Then we add b squared over 4a squared and subtract c over a from each side of the equation. And then put the right-hand side of the equation all over the denominator 4a squared. Now I'd like you to look at this quantity b squared minus 4ac and just keep it in mind because we're going to come back to it in a little bit. The next step in the derivation is to square root both sides. The square root of the left-hand side is simply x plus b over 2a. And we find the square root of the right-hand side by taking the square root of the numerator, which is b squared square root of b squared minus 4ac, and the square root of the denominator, 4a squared, which is 2a. And we remember to put the plus or minus sign there. Next, subtract b over 2a from each side. Put the entire right side over the same denominator, and there's our formula. And again, this formula gives you the two values of x that make the original equation true. Now there's another derivation that uses substitution. Again, this is not something you're going to be responsible for, but I want to show it to you because it uses a technique that you may never have seen before in an interesting way. Now, we start by multiplying both sides of this equation by 4a. We'll now use the distributive property and turn this equation into this form. And then we're going to be doing another unusual thing. We're going to find the term 2ax in various places. So first of all, 4a squared x squared is equal to 2ax squared. And if we kind of rearrange the pieces of the middle term 4abx, we can see that that is equal to 2b times the same 2ax, and then plus 4ac equals 0. Now we're going to make a substitution. We're going to substitute y for 2ax. And when we do that, the equation above converts to y squared plus 2by plus 4ac equals 0. Next, we complete the square, taking y squared plus 2by and completing the square inside the parentheses, adding b squared inside, and then subtracting it outside. And then we factor, add b squared to each side, subtract 4ac from each side, and there again we get b squared minus 4ac equals y plus b squared. And now I'll tell you a little bit more about that b squared minus 4ac. The left-hand side of this equation right here is positive. If b squared minus 4ac is 0 or greater, in other words it's not negative, then we can continue by taking square roots of both sides, and we can find a solution. If b squared minus 4ac happens to be negative, then its square root in the real numbers is not defined, and there is no solution. So let's square root both sides. Now I get y plus b equals plus or minus the square root of b squared minus 4ac. Subtract b from both sides. And then we remember that y equals 2ax. So now we're going to put back the 2ax. And now to find x, we can divide both sides of this equation by 2a. And there we have our formula. Now, that b squared minus 4ac is a small part of the quadratic formula, and that is called the discriminant. And we are going to use the letter capital D to represent the value of the discriminant. And that value tells us how many solutions a quadratic equation has. If you find the discriminant is greater than 0, then the quadratic equation will have 2 solutions. And if it's equal to 0, the equation has 1 solution. And if it's less than 0, as we saw just a few minutes ago, then we know that the equation has no solution in the real numbers. Now, here is the best way to use the quadratic formula. I'm advising you not to plug everything in at once because it's often the case that errors creep in, and it's much easier if we do this in a stepwise manner. So, given a quadratic equation, the first step is going to be to determine the values of a, b, and c, compute the discriminant, b squared minus 4ac, and then take a look at its value. And if the discriminant is positive, we compute the value of x, and then evaluate the 2 values. Here's an example. Given x squared plus 3x plus 2 equals 0, we see that a equals 1, the coefficient of x squared, b equals 3, and c equals 2. Now we're going to compute the discriminant. That would be 3 squared minus 4 times 1 times 2, and that equals 1. So the discriminant is 1. It is greater than 0, so we're going to compute x equals negative 3, the opposite of b, plus or minus the square root of 1 over 2 times 1, and that equals negative 3 plus or minus 1 over 2. Now we evaluate that formula for the negative case, so negative 3 minus 1 over 2 is equal to negative 2, and negative 3 plus 1 over 2 is equal to negative 1. So we see now that the solutions are negative 2 and 1. Now here's that same process, And I'd like you to try it on this equation that we've seen before. Stop the video, work it out for yourself, and then restart the video to see the answer. Okay, A, B, and C are 3, 1, and -2. We're going to figure out what the discriminant is. So that would be b squared, 1 squared, minus 4 times 3 times -2. And that equals 25. And you have to look carefully because that's 1 squared minus 4 times 3 times -2. 4 times 3 times -2 is -24. 1 minus -24 is 25. We now compute the answers for x using the value of d, and that would be equal to -1 plus or minus the square root of 25 over 2 times 3. That is equal to -1 plus or minus 5 over 6. And evaluating each of those answers, x equals -1 minus 5 over 6 equals -1, and x equals -1 plus 5 over 6, that equals 2/3, and those are our two solutions. The thing to remember, and the hint that I'd like you to write down, is to watch signs of A, B, and C when you're computing the discriminant D. Here's another example. Please try it on your own. Stop the video, and then start it to see the solution. Okay, first, A is 4, B is -12, C is 9. We compute the discriminant -12 squared minus 4 times 9, and that equals 0. Notice that -12 squared is positive 144. Okay? Now, since the discriminant is greater than or equal to 0, we compute x equals 12 plus or minus the square root of 0 over 2 times 4, and that is equal to 12 over 8. And we can simplify, and we note that there is only one solution, 3/2, because 12 plus 0 and 12 minus 0 are the same. Now the hint here is remember that when b is negative, b squared is always positive. You're squaring a negative number, make it positive. Here's another example. 2x squared plus 3x plus 5 equals 0. Stop the video and restart when you've finished the problem. Okay, A is 2, B is 3, C is 5. We're going to compute the discriminant, 3 squared minus 4 times 2 times 5. That equals -31. Now, we see in the next step that this indicates that there is no solution. Why? Because if you evaluate this for the discriminant equals -31, you'll see that it involves the square root of a negative number, and that is undefined in the real numbers. So when the discriminant is less than 0, there is no solution. Here's another example. Again, stop the video to work it out by yourself, and then restart to see the solution. Okay, so here A is 1, B is 4, C is -1. We compute the discriminant, 4 squared minus 4 times 1 times -1 equals 20. And here again we have to watch our signs. 4 times 1 times -1 is -4. So this is 4 squared minus -4, which is 16 plus 4, which is 20. The discriminant is greater than or equal to 0, so we compute -4 plus or minus the square root of 20 over 2. And then we evaluate. -4 minus the square root of 20 over 2 is about -4 and 24/100ths. And -4 plus the square root of 20 all over 2 is about equal to 24/100ths. Here, remember, if you're computing and estimating this on a calculator, be sure that you put the parentheses around the numerator if you choose to do the computation all at once. And that would be -4 minus the square root of 20 in parentheses, and then that whole thing divided by 2. Another example for you. Stop the video and restart it when you've worked it out. Okay, so here a is -2, b is -4, c is 1. Here we compute the discriminant, -4 squared minus 4 times -2 times 1, and that equals 24. That's 16 minus -8, that's 24. Since d is greater than 0, we compute the values of those quantities, 4 plus or minus the square root of 24 over -4. And then we evaluate for the plus sign and the minus sign, and you can see the two solutions. And remember, when b is negative, the opposite of b is positive. And that's why if we go back a couple of steps to this step, you'll notice that it is 4, positive 4, plus or minus the square root of 24, because b is equal to -4. So watch out for that. And then here's one final example. Okay, first, notice that in the example, this is not in standard form. This is x squared plus 10x minus 10 equals -3. We need to add 3 to both sides to get x squared plus 10x minus 7 equals 0. Then we see that a equals 1, b equals 10, and c equals -7. We work out the discriminant, which ends up being 128. We do the computation, and we find that those are the zeros. So remember, the equation must be in standard form in order for this formula to work. And this concludes the video.